Hi students, in this video we will be solving question number 17 from the exercise 10.2 of the chapter straight lines, and this is a first PU syllabus. You go to playlist and look for straight lines. In that folder you will be able to find all the sums related to this chapter, and also you can find the derivations related to this chapter. Let us check question number 17 now. The owner of a milk store finds that he can sell 980 liters of milk each week at 14 rupees per liter. There is a milk shop. The seller can sell 980 liters of milk at the selling price of 14 rupees per liter and 1220 liters of milk each week at the selling price of 16 rupees per liter. By looking at this, what can we understand from this is, as the demand is increasing, price of the milk per liter is also increasing. Check this, 980 liters of milk he can sell, that is when the demand is 980 liters, the selling price is 14 rupees per liter. But when the demand has increased to 1220 liters, the selling price is rupees 16 per liter. So as the demand is increasing, selling price also increases. Okay, you got the logic now? Yes. Now let us check the remaining part of the question. Assuming a linear relationship between selling price and demand. What do you understand from this? Assuming a linear relationship. That is, as one variable increases, the other variable is also increasing. There is no fluctuation in the second variable or the dependent variable. So that is why the relationship is linear between selling price and demand. If so, how many liters could he sell weekly at rupees 17 per liter? So if the selling price is to be fixed as 17 rupees per liter, how many liters of milk will be in demand? That is what we have to find now. So assuming the relationship between selling price and demand is linear, I have written whatever the statement is given. Now we'll consider rectangular coordinate system, and along x-axis we will consider selling price, and along y-axis we will consider demand for the milk. Now from the data, if we can see that this is the selling price and this is the demand, we get a point in the rectangular coordinate system, that is 14, 980, and this is again a selling price and this is the demand of the milk, then it is 16,220. You plot these 2 points on the rectangular coordinate system, we get 2 points here, and if you join them, we get a line segment. So actually, how will the point look like? It will be like, instead of x comma y is selling price comma demand. So selling price represents x coordinate and demand of milk represents the y coordinate. Now we know this is a line segment. When you know that this is a line segment and you know 2 points on it, we can always find the slope of that line segment. First, let us do that. M is equal to y2 minus y1 by x2 minus x1. Now, this sum can be solved in 2 ways. One is by finding the equation of this line segment, we can find the demand of the milk. The other way is to consider these 2 points and this as the third point, 17 liters, comma, some y, which we have to find. Y is the demand of the milk, and we can call these 3 points as A, B, C. Then we can find the slopes, like slope of AB is equal to slope of BC. Equating both the slopes, we can find the y coordinate, or we can find the demand. But now I am choosing to find the equation of the line and find the demand of the milk. So now slope will be 1220 minus 980 whole divided by 16 minus 14. On simplifying, we get the slope to be 120. Now when we know a particular point on the line and the slope of the line, we can always find the equation of the line, which is y minus y naught is equal to m into x minus x naught. So slope we have found. For x naught, y naught, we can consider any of these 2 points. In this case, I will be considering 14, 980. So I'm writing that data here. Now we will substitute the values for x naught, y naught and slope, which will be y minus 980 is equal to 120 into x minus 14. I am retaining this expression in the next slide also. So moving 980 to the other side, y is equal to 120 into x minus 14 plus 980. Now we have got a linear relation between selling price and demand. Now you put any selling price, we can find the demand at that price. We will put the selling price for x as 17 rupees per liter and we can find the corresponding demand. So we shall do that. Y is equal to 120 into 17 minus 14 plus 980. On simplification, we get the demand or Y value to be 1340. So the owner can sell 1340 liters weekly at the rate of 17 rupees per liter. Or we can also understand that when the demand for the milk increases to 1340 liters per week, the selling price would be 17. Hope it is clear, students. If you still have any doubt, please do mention it in the comment section.